Oh, hello. Okay, it was a long flight. I would like to thank the organizers for bringing me out here, and the sponsors as well. I spent a lot of time on this artwork over here, and then I saw that they're doing this screensaver in between, so anyhow, it's kind of a brain thing, you know, the inside of a brain. Okay, let's go. First of all, the tools. I will be discussing a whole lot of different tools today. All of the tools that you're going to see here is free for download. At the end of the presentation, I will give you a list of URLs where you can download these tools. Again, there's a standard disclaimer. If you use this against any targets that you do not have a mandate to operate on, then we don't take any responsibility for that, right? I think that goes without saying, but I have to say it. So, just a quick thing. This is the agenda. I'm going to really quickly talk about SensePost. The marketing guys back home, tells me that I have to do this, but I'm going to keep it, 2 or 3 sentences. We're going to look at the introduction, why we look at these things, why these things are interesting for us at all. We're going to look at network application level testing, where I'm going to show you the tool called Wecto. Can I just see a show of hands? Who's played with Wecto before? Okay, only those 3 guys there. Seems they've got a little Wecto nest there. And then we're also going to look at application level testing. 2 tools that we're going to look over there. There's a tool called Crowbar and a tool called EOR. And I'm going to hopefully be able to show you some demos of that as well. I've got a connection to the internet here. I've got a target locally as a VMware machine. So hopefully we'll have the time to go through a little bit of playing with the tools. We can try to do that while I'm talking, but I suspect that we're going to run out of time. I think we're behind schedule a little bit already, and that's going to go into your lunchtime. So we'll see how it goes. Maybe some of the stuff I can show real quick. And then we'll do a conclusion and some questions. So this is basically what we're in for the next couple of minutes. Okay, you will see that I don't even have a slide that says Introduction to SensePost, so I'll quickly talk about it. We're a company in South Africa. We started in 2000. We're now about 15 people in the company. We're not a large company. We try to focus on quality rather than quantity. We do assessments, we do training, and we do research and consulting. So on our assessment side, most of the time we look at perimeter security, assessing perimeter security, and assessing web application security. Okay, that was the introduction to SensePost. Introduction to this talk, basically, if you're looking into breaking into a network or securing a network at the other side of the spectrum, there's a couple of things that you want to look at, right? First of all is finding the network. So you would see that SensePost spend a lot of time on doing footprints of networks, doing footprints of large organizations. You can then go one level up and look at the network level. That's basically finding out what services are exposed. When you're looking external to networks these days, you would find that there's not a lot of there's not a big attack surface to attack against. So you mostly look at port 80, 443, and port 25. There's not a lot more exposed in large corporates these days from the internet footprint. We can then move one level up to the network application level. And that basically sits, for me, anything between the network level and the application level. So this is where we look at patches and that kind of thing, but we'll go into that a little bit more in detail. And then you can also go one level up from that, where you go into the application level. And this is really where stuff is starting to get interesting these days. I think it's the new frontier for a lot of the problems that we see, and a lot of the attack vectors nowadays actually happens on application level. So in the talk, we'll spend a fair amount of time on the application level itself. You can go higher than that, of course, and look at content level look at worms, viruses, trojans, that kind of thing. And also look at some of the other vectors into a network, which could be wireless, third-party connections to other networks, RAS networks, social engineering, physical access, all of that. But we're not going to spend time on that today. So, why do we actually worry about these things? On a network level, finding the network is really one of the most important tasks. There's a way of saying we rather find the vulnerability on one machine than finding, basically doing a scan of the entire network and finding a vulnerability somewhere than trying to find a specific vulnerability on one machine, right? And many of these companies have very large networks that are span across the whole globe. They have multiple ISPs, which means they have multiple entry points into the internet. They have thousands of domains in multiple countries. It's controlled by different groups of people speaking different languages in different time zones. And in many, many cases, the organization itself doesn't actually even have an idea of what they have exposed to the internet. Okay. Now, we have a tool that's called, that we released at Black Hat 2005 in Las Vegas this year, called BDBlah. The URL is there on the board, on the screen. If you want to look at finding networks and finding net blocks and vulnerabilities within machines, I suggest you look there. I'm not going to talk about it today simply because we don't have the time to look at everything, right? Then on the network application level, that's really the patching game, right? That's, do you have all the necessary updates installed? Do you have the patches installed? That kind of thing. I think everybody is quite comfortable with how that works and how that sits together and what kind of problems we're looking at there, right? On application levels, things start to become a little bit more interesting because normally, in a normal sense, normally you have a security officer that is used to set firewall rules and that is used to apply patches on machines. But on application level, the problem lies with the developers of that particular application. So it's suddenly a whole different crowd of people that you're dealing with if you want to fix something on the application level. Okay, and most of the time, people that code web applications are not that security aware. They come from a developer background. They don't come from a security background, right? So the problem is really difficult to solve. You find that the people that defend networks, typically the guys that apply patches and on a network level work with the firewall, don't have a development background. And a lot of the time, these two groups of people are also not very comfortable with each other as such. So it's really a difficult situation. We find that nowadays, and it's changing, okay, it's changing all the time, but the skill level of attackers against against web applications, or even thick apps, are higher than the defending capabilities of that of developers, which is a tricky situation. The other thing that's also difficult to determine is if your app is really broken or not. So you have a situation where you have a customized application that runs on a web server, and there's no notification coming out from Microsoft or Sun or whoever saying there's a problem with this particular version of your application, correct? We can't get an alert for that because it's a custom built application. That makes it very difficult to work and basically determine if your applications are broken. It makes it a very difficult space for companies to defend. Now, in this talk, we're going to focus on basically those two ports. Like I said, if you look at a company externally, you'd find that most of the time you have port 80, 443, and 25 open. So for now, we're going to focus on port 80 and 443. Now, 443 is not really much different than 80. It's HTTP versus HTTPS, and with HTTPS we're only having SSL on top of HTTP. So all of the tools that I will be discussing in this talk now have SSL support built into it. Normally you had to put it through a proxy, a SSL proxy, but we have support now for SSL within the tool itself. Now, on a network application level, we really look here at a family of attacks that's called CGI scripts, right? So a lot of the tools out there, Nessus, Nikto, those kind of things, basically look for scripts and basically look for certain pieces of scripts that are sitting on the web server itself. Remember, this is not on application level. This is still on a network application level. Okay, so they look for sample scripts for interesting files. They look for encoding problems, sanitization problems within known applications. And they might look for cross-site scripting within known applications as well. This is all known applications, sample applications, that kind of thing. And basically, what happens is the scanner would send a request for this particular resource and determine if it's there. And if it's there, it would tell you showcode.asp is on your machine. You should look at it. On the non-commercial side, the players in this is really, there's only really two scanners. There's Nikto that is using RFP libWhisker, and there's Nessus, right? Those are the two main competitors for this space. Now, the problem with almost all of the scanners that's out there is that there's a couple of things that they really do well. So, for instance, they don't really intelligently look at responses. Okay, and I'll elaborate on that a little bit more. They also don't do CGI, initial CGI directory mining. A lot of the scanners out there determines, before it starts, have to determine what the CGI directories are, what directories on the servers is marked as executable. And if you don't have those, you could miss a lot. They also don't do recursive scans for directories. So for instance, it would scan for a directory called admin, but it won't look in that directory admin if there's other directories available there as well. The result of this is that we miss a whole lot of stuff. We get loads and loads of false positives depending on the application, depending on the web server. And generally speaking, nowadays it becomes harder and harder to actually perform this kind of scan. So let's look at it in a little bit more detail. Remember, when you send a HTTP request, there are HTTP replies coming back, and that HTTP reply has a status code, right? So you know 404 means the file is not found. You know 200 means the file is there, so forth and so on. Now, web servers can be configured to reply with what friendly. Now, what is a 404? A friendly 404 basically means that we get a response back from the server saying that the location is incorrect or that the resource cannot be found. But it's not marked with a status code of 404. It's marked with the status code of 200. Right? You've seen this before, right? You browse somewhere, I think Yahoo, those kind of places. You get a page coming back that's a really friendly message that says, you know, the file is not here. I'm very sorry. But that response code that is coming back not with the 404. It might be coming back with the 302. It might be coming back with something else, but it's not coming back with the 404. And this we call a friendly 404. Okay. Now the problem with this is when we test something, we test if we want to see if that resource is there, and we get a response back with a 200, not with a 404, correct? And now what you get is that the scanner thinks that everything that it's testing for is on the machine that it's testing. So I don't know how many of you are using Nikto. Can I see show of hands who's using Nikto or you used it before? Some people? Yes? Okay. You know that message over there that says over 30 moved messages. This might be a byproduct of the server answering all requests of 302s or 301s. Moved message. You should manually verify results, which means you can't really do the scan, right? Now, if you look even in more detail, and you look into the Nikto database, you would see I'm listing 2 entries there. If you look at those 2 entries, the first entry is basically looking for the directory called cpanel, right? And it will trigger a positive when HTTP 200 is returned. So that's what it's looking for there. Okay, and that's the response, the error code, the status code response that it wants back. So if it gets a 200, asking for cPanel, it would tell you cPanel. It will actually tell you web-based control panel exists on this thing. Whoops. Right? The second one is a little bit better, because the second one asks for /gwweb.exe (help equals bad request), right? And then looks for could not find the file sys in the response. So that's much better. We actually look at very detailed responses coming back. If that thing comes back as a could not find the file sys, it will trigger and say group-wise allow system information and file retrieval. Right, is that only about 25% of the Nicto database have entries that are built like this. So we're sitting still with the problem that 75% of the rest is looking at the status code and is thus very vulnerable to false positives. Now, how does Nessus do it? Now, the information that's here is a little bit outdated. I don't want to go into how Nessus do it at the moment, because it's even a little bit worse than it is now. Nessus has a plugin called no404.nasal, right? That tries to address the problem. How does it work? Before any of the CGI type checking in Nessus runs, it basically asks for a non-existent file, right? And then it matches it up with a whole lot of set of different predetermined responses that it could get. And any response that it gets that was marked in that list, right, is now treated as a false positive. So that seems to be a good way of doing it, but it also doesn't work all the time. And what's the problem here? Well, the problem here is that it works fine when the actual response is, the response for an unknown resource is consistent, right? If that response is consistent, it works fine. But the problem is that certain extensions, if you're calling a different type of extension, for instance, .servlet, could be handled by another subsystem. And that subsystem might react in a different way. So your response messages are still a friendly 404, but it's not the same kind of friendly 404. Okay? And it could be that certain parts of the application within a certain directory is mapped to a different machine, right? And if that machine replies with a different error code, then you still get your false positives. Okay? So it's a start, but it really breaks too frequently. So what we actually need is we need something that doesn't look at status codes at all. That's totally status code independent. That is sensitive to extensions, so different extensions could have different messages, and that is sensitive to the location within the application or within the web server, right? Now, this is what Wikto does. I'm going to skip this slide. I might come back to it later on. The logic within Wikto works as follows. Okay. When we get a request, when we're asking for something, it could be anything, we try to, from that request, extract both the location and the extension of the request, right? We then request a non-existent resource with the same location and the same extension, right? We store the response for that particular thing. Then we send the real request out, okay? And then we compare the responses between the real request and the bogus request, but it's sensitive for extension and it's sensitive for location. If these two requests, the output of these two requests matches, they match, then we know that it's a false positive. So let's take an example. There would be a NictoDB entry, for instance, called /scripts/showcode.asp. Now, from that, if we extract that, we know that the location is /scripts. We know the extension is .asp. And so what we request is a non-existent file, /scripts/moo.asp. Actually, in Wikto, we don't request moo. I think we request something else. But you get the idea, right? Let's say we get the response, HTTP 200 OK, your file is not here. This is clearly a friendly 404, right? We now request /scripts/showcode.asp, and let's say it's not there. We're going to get the same response, right? HTTP 200 OK, your file is not here. We get a friendly response. We compare the two on a content level, purely on a content level. And if on a content level these two things compare, then of course the test is negative. If however showcode.asp was really on the server, we would get a totally different response. And so if we compare the content, we'll get a different response, and it won't compare in content, which means it's a positive. Okay, where's that telephone? Right. So what does it look like? This is basically the... does anybody have a laser pointer perhaps? No? Anyone? Because I have one, and then I put it in my pocket, and then the switch goes on, and I walk around with this red dot in my... We don't want to go there, right? Okay, no, this is fine. Excellent, thank you so much. Thank you so much. So if you look at this, this is basically the Wecto part of Wecto. What you have over here is a little button for SSL if you want to do SSL. And it then runs through all of these requests. You can see that there's a little button there that says use AI or use fuzzy logic, right? And that's basically the level that we set up, the trigger level, in terms of the comparing of content. So if the trigger level is set very high, let's just think about it. If the trigger level is set very high, it means we're not very paranoid. If the trigger level is set very low, it means that we really want to make sure that it's not the same request at all. So you can actually set that level. And you can then, while it's running, click the update button, and it will show you the results in this window. If we have time afterwards, I'm going to run through this. I'll show you how it works. So this is in real time, shows you the request, and it shows you the response at the same time. Also gives you a description of the problem, and so forth and so on. Okay. Now, what were the challenges that we faced when building Wecto? Actually, it's really simple. It's not a big issue to build a thing like this. The only thing that was a little bit tricky was the extraction of the location and the extension. So for script showcode.asp, it's really obvious, right? The location is scripts and the extension is .asp. But it gets a little bit tricky when you have something like this. Okay. Now what's the extension in that thing? Is the extension MDB? Oh, it's not really, because this thing is actually a parameter that's passed to a script. So in fact, the extension of this is blank. I do something, doesn't have an extension. What's the location? Well, I mean, there's the Unicode representation of a slash. There's 2 dots, there's 1 dot, there's 3 slashes. What's the location of that? It starts to become extremely difficult to determine exactly what the location extension of that is. Luckily, we don't have a lot of them. Okay, there's not a lot that's like that. The other thing that was not really tricky, but we kind of skanked out on, was the comparing of responses. I'm doing a very, very simple kind of correlation within words, within the, or characters within the different responses. It's an autocorrelation function. It's very simple. At the moment, it seems to be working fine. So I'm going to leave it until someone complains about it. And the rest of the stuff is actually just, you know, just coding. It's just programming this stuff into a kind of interface. It was really not that difficult. Now, one of the things that we like to do is we like to feed some of these ideas back to the community. And we thought that one way to do this was to also look if we can improve the scanning capabilities of Nessus in the CGI scanning. Now, most of the plugins that's looking for CGIs is using the is CGI installed KA, that KA is for keep alive, to determine if a CGI is there. So basically what we did is we took the function out, we rewrote the function, and that it doesn't look for status codes anymore, and that it only does vector style checking. And what's nice about this is the responses we can now store in the KB, which is the knowledge base, right? This is this kind of database repository for per machine within Nessus. So we can take the responses, store it in the KB, and then obviously we don't have to look at it again. We can just wait for it to be cleared when the KB is cleared. And it works really well. And we made it a kind of a drop-in replacement for that function so that you can just, take that function, rewrite it, drop it in there and immediately get all the benefits of it. It works really well. We've seen a very dramatic improvement on false positives where server responses differ in terms of location and extension. Are we talking 8 false positives versus none? It makes the KB a little bit heavier, right? Because it's got to now store all of the responses per location and extension. So it increases the KB size with about 120K per host. And of course, the initial scan that you're doing on the box would be a little bit slower because we've got to send all our bogus requests. But afterwards, then we got the stored responses. Then it's really quick. We can maybe talk later on what happened to this when we submitted it, but I think now is not a good time. Now, there's some other cool things that Wikto is doing as well. And this is basically things that we just kind of put around this to make the whole integration, make the application integrate with different little tools that we have. One of the things, if you Google for Wikto, you'll see that it only almost gets mentioned for its capability to do Google hacks. What that we do is we mine directories in common files /admin/login.asp. We kind of mine for those files. Remember I said that one of the shortcomings of most of the other scanners is the fact that the initial CGI directories is not populated properly. So now when we mine directories, we can take that stuff into our Wikto scan as CGI directories. We also we use the same fuzzy logic principle when we're looking for directories, right? So because we have now the capabilities to know what are false positives and what not, we can use it very easily to determine directories, and we do that recursively. I'll show you in a bit. We can also do the other way of finding directories on a machine is basically also to do a mirror of the site. Okay, so you do a mirror of the site, and from the mirror you actually look at all the locations and you extract the directories from there. Now what's interesting about that is you can now take those directories and import those directories into your backend miner that looks for other directories within there. So to give you an example of that, if you, for instance, is a bank and your bank is called Tiger Bank, sorry, and your whole site sits under a directory called Tiger Bank, right? Then normally if you scan for administrative backend and you scan for /admin, you're never going to find it, right? But if you know that Tiger Bank exists as a directory and the whole site is located behind that directory, once you did the mirror, you're going to find /Tiger Bank, right? And if you import that then into your directories to check for, because it's recursively, it's not going to check for Tiger Bank /admin. And if it's there, okay, that's something you want, right? So we do that, and I'll show you how that works as well. We also have a thing that we call the Googler, which is basically doing directory mining as well. Basically what it's doing is it's going out to Google, and it's asking Google for, it has certain terms that it adds, and it basically just does a Google search and look at the results coming back. Now, if something sits in www.tigerbank/welcome.asp, then of course I know that the directory Tiger Bank exists. Okay, this is really simple, but it works really well. The other thing that we also do, these directories can now be used as input for CGI DIRs, right? The other thing that we also do is, while we're busy with it, we fingerprint the server. So we want to get the true server version, the actual banner, right? And we don't look at the banner. We basically use NetSquare. Is the NetSquare guys here? Who's there? I know that they're at the conference, but okay. They've got a tool called HTTP print. We always joke about that because we call it HTTP rint, right? They have this tool and it's integrated within Wikto to basically do that kind of fingerprinting as well. And then last, but not least, we do Google hack scans against the site using Johnny Long's database. And this is, you can automatically update the stuff from his site. The tool has the functionality to do that for you. And it's funny, people only read the last part here, they miss the rest. So let's have a look at it. This is what the, hey, you know what, let's just go live and hope that we don't break stuff, okay? And as you know, it's always difficult giving demos because normally everything works up to the time that you actually check it. What I'm going to do now is I'm going to go and mirror for, you can set it up, right? The mirror time is set up here, 60 seconds, and a test depth of 4 levels within the mirror. Okay, so what I'm going to do, just as to show you how it works, and please, it's not a hack against anyone, right? It's just doing a mirror of the site and extracting the directories. So I'm going to look at www.cnn.com, and I'm going to let this thing run at this side, and it's now basically doing the mirror for 60 seconds. You can set it to mirror as long as you want, of course. And then from the content that it gets back, it's going to extract the directory structure from there, right? That they're running. While it's doing that, we can quickly go here. I can show you this is the backend database. So basically what we're going to do, the backend database, the backend miner, basically what it's doing here is it's checking for all of these directories over here, right? And if it finds a directory in here, it's going to check for these files in there with these extensions. Now what we've built is, we built a little button over here that says update from SensePost. And you click on there, you get different categories, right? Standard, quick, and full. I'm just going to go for standard. And if I click on this here, it basically updates those directories and files that we're going to look for. So if we find something that we think is nice and you should have it as well, we populate some file that says on a website at our site. Where you click on that button, then it basically pulls that information. Okay, so it can kind of keep you updated with that. On this side, you'll see now, one of the things that it also does is it looks for links external to that site, which is always interesting, right? If you know that they link to someone else, that they could show in a relationship. So you see here, there's a whole lot of sites that these guys link to, cnn.co.jp. Those are just external links from that site. I just give it because it's interesting to see. And on this side, you have a list of directories that could be extracted from the actual site itself, from that mirror that we've done. Okay, so it's quite a lot, right? See interesting things, audio, radio, all of that, okay. On the banner side, that site reports itself only as Apache, but with using HTTP, screw that, print. We know that it's in the 2.0.x family of servers. That's what Samuel and the guys from NetSquare is telling us. On the backend side, we can look at a machine that I have as a VMware machine here called intranet.sensepost.net. You would see that it's now going through all of the directories there, okay, at a rather quick pace. I'm going to stop it right there. You'd see that it has /admin in blue, right? If it's in blue, it means that it's indexable as well. And then it also found /admin/backup. So if we look at the site itself, we can go to admin, and we find that it is indeed indexable. Oh, and we find that there's a backup directory with a file called bigdeal.html, which is a secret file. Okay. Right. We can go to the Googler itself as well. Let's do the same thing over here. It works with the Google API. I'm going to put in the fact that it should look for HTML, ASP, PL, PHP, CGI, ASPX, and so forth and so on. And if we run, so if we look at the site itself, we can go to admin, and we find that it is indeed indexable. Oh, and we find that there's a backup directory with a file called bigdeal.html, which is a secret file. Okay. Right. We can go to the Googler itself as well. let's do the same thing over here. It works with the Google API. I'm going to put in the fact that it should look for HTML, ASP, PL, PHP, CGI, ASPX, and so forth and so on. And if we run through there, it's using the Google API, and it found all of these results over here, right? Now, as soon as it finds the results, this is for HTML and HTML. It populates this list over here. Okay, you get the idea, right? What's nice about this is, of course, if I go back to this, to my backend miner, I can now say import the directories from the mirror, and immediately at the end of this, it would import all of the directories that it found on CNN. If I now start running this process, it will immediately start looking for all of these directories within those directories as well. You understand why it's interesting, right? On the Googler side of things, if we go down here, okay, that's the API not working from Google side. But you see here's a lot of PDFs. Here's, in fact, some doc files. You'd be surprised at what people put on their machines that gets indexed someday by Google. Okay, and at the end we also have the Google hacks. You can load the database, and that's the Google hack database basically sitting down here. On the system config side of things, on the system side of the system config side of things, you can update the Necto database and update the Google hack database right there. Just clicking on that button, and then it updates by itself. With Victo, I can load that database, and what I'm going to do is I'm going to run it against that VMware machine of mine, and let's put this in as /scripts. Okay, and you can see there it's running, and there's the requests coming back. Okay, there's the track trace thing that you also always see within Necto itself. I'm going to close that. I'm going to go on with the presentation because I think time is not a lot. Okay, you've seen all of this, right? Now, the next thing I want to talk about is a thing called Crowbar. How much time do I have, by the way? I'm not sure. 15 minutes. 20 minutes? Ooh. Okay, we started a bit late, but okay, I'm going to run through this as quick as possible, so I won't give you a demo of this. Basically, on the brute force, Crowbar is a brute force attack tool that basically does generic web application bruting. Okay. At the moment, we're stuck with things that try to be too smart in terms of a brute forcing tool. So it tries to extract the fields and it lets you populate those fields. And I said, I don't want to do that. So basically what we have here is a thing that on this side at the top, you put in your actual request as it appears, right? The actual HTTP request. And you set up a whole lot of different parameters here. You can have an inner loop and an outer loop, so you can brute force two parameters at the same time. And in this case, the only thing that I did was here going to google.com and going to the answers page for the FAQ page. Now, all of them has got a little index, right? It's got an index that says it goes to answers.py, which is probably Python. Question mark, and the parameter that we pass along is answer, right? And I've said with answer, basically run that from 15,000 to 16,000, and let's see what comes out. And I can do some content extraction over there with a start token and an end token, and Crowbar will show me the stuff that's sitting in between, right? So basically here you see that it's run through all of these with the number, and the token extraction gives you the question, and that's the answer for that particular FAQ. Now this is one way you can use it. Another way you can use it is by, for instance, doing a brute force attack. Like in this case, this is access to our chat room that we have on our site. You'll see it goes to a certain IP address. It's got an action called login. It's got a name that says test and a password. And my password I now read from a list of passwords, right? This #1##, could be sitting anywhere within this whole thing. It could be sitting in the cookie, could be sitting in what I request, could be even sitting in the content let if you really want to do that, right? And basically what's happened now is the same algorithms that we use for comparing content between requests within Wikto is used in here as well. And we have a base response that you build up. And from there, everything is measured against this base response. The content is measured on here. So we don't have to know what a positive actually is, right? We don't have to know what a screen looks like when a login has succeeded. Because the content of a login that succeeded will differ significantly from our base response. And this fuzzy logic triggers we can control on this side. Basically says, make it equal to this, make it not equal to this, show me everything. Show me things that are within this high and low. Show me stuff that's outside of this high and low watermarks, right? And here you can easily see that after a bit, we got this password, this pin cracked on SensePost with the username of test and a password of blah. Okay, so it's a very generic web brute forcing tool, and you can brute force two parameters at the same time. I've got a demo of this as well for this site, but I suspect that we're going to run out of time in a big way. Okay, so I'm not going to show it. I'm rather going to go on. What do you prefer? Going on with the presentation? We got the application level stuff coming up, or would you rather go for the demo? Demo? Hands for the demo. Hands for the demo. Okay, hands, sure. Hands for the continuing to application level stuff? Okay, there's more for that, so I'm going to go on. We can do the demo afterwards if you want to. Okay, it's really easy. All right. Now, on an application level, that's anything that resides on top of the web server, right? And it's anything that talks to a database or that kind of thing. So normally that's your homegrown application that runs on top of it. And it's difficult to fix it because, and we talked about this, you can't download a patch for it. I've seen many guys when we show them difficulty within or problems within their web application go, okay, where's the patch? I go, well, there's no patch. Speak to your developers. Firewalls is useless. Okay, you have 80 going through. If the firewall is not application aware, and most firewalls are not application aware, your firewall is useless. Your IDS is almost useless. If it's SSL, it's even more useless, okay, because it's encrypted. It's very difficult to detect an attack on an application, even on an application level. So very little applications are aware that they are being attacked. Okay, you have these applications frequently talking to databases, and databases, as we know, contains interesting information. We also find that these databases and application servers, if there's a staging between application and front end, are located within internal networks. So if we can break something in there and get commands to execute, we are actually executing on the inner perimeter of the network, right? Outside of the DMZ. And traditionally, developers and security administrators are not good friends. So what's the kind of attacks that we do? System level. I'm not going to go through this because I expect everyone here to know these things. Okay, you have file system and directory traversal attacks, command execution, SQL injection, cross-site scripting, impersonation attacks, parameter parsing. All of these things are things that we can test for. Now, what's the difficulty in writing a web application scanner? Well, first as we can, but it doesn't work. And it doesn't work because maybe the first link that you mirror is the logout button. So what happens is you log yourself out as soon as you start mirroring, and the rest of the application, because the session ID doesn't live anymore, is now gone. Right? You have forms that keep on repeating, like a calendar. Right? You click on the next day, and the next day, and the next day, and 2 weeks later you come in there, and this thing is like, you know, in the year 9000, and it's still mirroring that application. Right? You have problems in that certain sections of the application might be hidden until you provide correct parameters, right? You also have the problem that you can't interpret your results. Okay. For instance, if there's an authorization problem within an application, and I can read someone else's balance of an internet banking site, how do I know that it's someone else's balance that I've read? Understand what I'm saying? It's very difficult to actually interpret the results that you're getting back. The other thing that is also difficult to do is, a lot of the time, the responses that you're getting back is only a frame set. So it's only a frame set, it redirects you to another page. So if you look at the results, normally on a network level, you only get that frame set, you don't know what it looks like. If there's flash involved in the response that we get back, how do we know what it is? Unless you can read flash by looking at the hex, I can't. So it's a little bit tricky to interpret even the results. Now I'm not going to go through this. The only thing that's interesting here is that we had an interface at some stage that caused mental problems in sensitive users. They needed therapy afterwards. So we kind of, we skipped that. And we're now sitting with a thing that is version 1.0.15, and we actually use it in-house. Okay. Now I'd like to show you this. Now the design criteria for EOR, the thing is called EOR. Right? We wanted to call it WebDonkey, but we couldn't because there was a WebDonkey already. So we called it EOR. Okay. Now with EOR, with the design criteria for EOR was that the user can choose which part of the application he or she actually wants to test. Okay. The user then walks the application, basically do a click through of the application, filling in whatever necessary information to go onto hidden parts of the application that a mirror can't get to, right? And what we use is we use Paros or the at-stake web proxy file writer to basically write to file as we click through this whole application, right? Not the whole application, whatever parts we want to test of this application. We want to give the user the ability to disable actions, for instance, log out, or actions that we know if we start messing with this action, it's going to kill our session ID. Right? We want to have the ability to hard code variables to certain other values. We want also the ability to keep variables as they were when the guy served the actual page. So the default of what that values actually were. And obviously, we then want to give the ability to fuzz certain variables. So we're going to give a whole lot of different strings that we're going to pass into these parameters. And we're going to ship it off to the web server and see what to the application and see what the response is going to be. And then the ability to configure fuzz strings in that. Now the interesting part is here is that we use a real browser to render the response. Okay? Because the best thing that can render HTML is a browser. Okay, you can get the HTML as a stream of text and look at it and look for keywords, but the best thing you can do is have a browser render it. So what we do is we let a browser render that actual request, render the response, and then we look at, we take a graphical snapshot of what the browser looks like at that stage, right? Plus, we find the text that sits within the browser and we put that into a file as well. So you have the graphical representation of what it looks like, plus you have the actual HTML that was returned to you at the same time. And then you can start searching through that content. And you can basically start viewing all of the responses as a kind of a movie, right? And if you see a flicker on the screen or something changes, you can stop and you can say, okay, show me exactly what was the different response, what was the different parameters and the values that I set up for this particular, that rendered this particular response. Okay, and then you can replay that request and say, now you can play with it a little bit further. So, as time is few, I want to not go through this, and I will show you what it looks like. Okay, so this application itself, the idea was that we crack this the password for this, but we don't have the time for that, right? So I'm going to log in here, and this application here is from Swiss Cheese Industries, right? It's something that we wrote. The reason why it's Swiss Cheese Industries is it's full of holes. Okay. Okay, so this application is really bad. It's really badly written and it's riddled with different holes. And basically what we've done is we've now browsed through this application, right? Recording every step that we've done. We can then go to EOR, okay, and load the actual request log, and it would give me two different views. The first view is the action view, where I see all the different actions, right? And I can drill down on an action. So for instance, if I want to drill down in customer.pl, that's not a good one. Let's take board.pl. It would tell me it takes 4 parameters: email, message, subject, and submit. And I can drill down on email, and it will tell me what was the value that I've submitted for email. But maybe you want another view on it from a parameter side. You click on parameters, it shows you all of the different parameters that was used within this application. Now imagine this is not a lot, but if you're sitting with an application that's 300 pages big, this list becomes very long, right? And I can maybe look at username. I click on that. It tells me the username was test@test.com. It will tell me all the different values that that particular variable could have. And if I click on this, it would tell me where, because remember, it could be different values, right? It would tell me exactly where, what action was associated with that particular value. Okay. So what I can do now is I can set up, for instance, let's set up a couple of variables. I can even do a search. So for instance, I want to get one that's nice. I go into name. I can see that it is support.pl, and when I switch over, you'll see here at the bottom, it always have that as a little text field. If I switch over to actions and I click on search, it would show me where support.pl is. Now, it looks really easy, but like I said, imagine 2 pages of these actions and parameters. And it's really nice to see how the whole application sits together. The next thing that I do is I actually go mark which variables I want to fuzz. I can say fuzz those, right? They become green. I say this variable I want to hard code to a particular value. It would show me the value that it was. And I want to hard code it to do it too. And the login button I actually want to disable. So I'm going to disable that, and you'll see that it changed to gray. Then I go to my fuzz fields. I load a couple of fuzz strings in. Okay, there's a thing that says for cross-site scripting. There's something for SQL injection, null byte parsing, directory traversal. There's a different kind of, and I can add to it as I want to, and I can load it from file or whatever. And then I actually do the fuzz itself. Now with the fuzz, I'm going to load a fuzz on fuzz, right? And you'll see that it opens up an IE browser that then does the actual request. It's got some timing there that tells you how long to wait before taking a screenshot. And it will go through all of these things and actually perform all of those actions. The state variables, in this case, in terms of cookies, that we want to change, right? Because we have to log in with the correct set of credentials to provide a correct session ID. This we can change. I'm gonna stop this, right? You get the idea, right? And I can resize all of this, and at 1024 by 768, it's kind of crappy. You should see it at 1600 by 1200. Then you can get all the responses that you actually want to. Okay, so let's just stop this. Right, in here you'll see the cookie, right? And this I can edit, so I can actually change this value to, let's say, test. Oops. And I say edit And so now every request that gets sent out will get sent out with this actual HTTP header. Okay? Because maybe you're testing this application 2 days after you walk the application, then the session ID would not be valid anymore, correct? I suspect that if I run it now, yeah, you see, because the session ID is now gone, it will ask me to log in, please. Okay. On this side, I can basically now load again a script, and it will show me the response in a small little window there, right? You see the response changing, and I can click on this, and I can say play, and it will go through the request there, and it will show me the responses. I'm going to make it a little bit faster. Okay, you see there, and if we go back here, oops, wrong button. Let's just play through there again. Okay. Oops. Hey, okay, go one frame back. You'll see over here that we have an interesting situation, right? Whereby we can actually do a command execution, right? By adding a character, pipe, dir character. I'm not going to go into the specifics of web application security, but you can clearly see there is a thing coming back that says directory of inet pub scripts coming back to us, right? And then we can go to the specific actual parameters that were sent for this particular thing, right? We can now replay that request. In this case, it would ask us to log in because we just trashed the actual cookie, right? But in any case, you would then go to the request and say replay the request. In this case, like I said, because we trashed the cookie, we now have to log in again. We can, if you don't trust me that it's working, we can quickly load that script again. Okay, of course that's blank. Let me run this in the background. Okay, we'll let it run through to that particular one, and then we'll stop it, right? Okay, I think it's close by. There we go. Okay, and I'll stop it over here. And I'll go to my yes. See, that's why you should have canned demos. Right. Okay, you must just trust me on this. I'll go to the more familiar screenshots. Okay. Right, so that gives you an idea of how the thing looks. Like I said, the fuzz strings, you've seen all of this. Challenges here, logic between parameters, values, action. It's actually quite difficult to get that tree sorted out. It's not that easy. Screenshots were a little bit difficult. Now, you would say this is a complex tool, but it's a complex problem. So there is no button that you can press that will do web application assessments for you. It won't ever happen because of the complexity of the problem itself. Now, given the design constraints that we put onto this tool, it's probably the simplest way that you will ever do a web application assessment with this tool. In fact, one of the things I want to do is I want to have a go at the application that they have up here with Zone H and see how this tool would, fare against that kind of situation there. We have a list of new features. I'm not going to go through all of the features because that's features that we want to implement. I'm not going to go through all of that because I know I'm taking the food out of your mouth. And finally, this is the location of the tools that you can download this if you want to take a picture of that or if you want to write it down. Everything sits within research. So we have www.sensebus.com/research. In there, you will find all of these tools. So it's /research/EOR/research/Webto/Crowbar. BD is in there as well. We didn't talk about it today, but if you want to have a look at it as well. And then finally, you'll see that we have the SensePost Research and Tools Google group. So if you want to join in there, if there's new releases of tools, I normally write a short little message to that group saying, you can pick this up at this location. It's not a posting, it's not a discussion list at all, it's just an announcement list, okay? So the traffic in that is really low, it's about once a month. Questions? Any questions? Yes? Yes. The one thing, that will probably be the route that we go in, okay? But for now, we just want to keep our options open. The chances is, I can tell you now, the chances is 95% that it's going to go open source. And then, of course, we'll make a project for it and all that. Any other questions? The one that you can download now, EOR that's there, it's fully functional. There's no cripple, it's nothing like that at all. Yes? Sorry? Oh, does it only run on Windows? Unfortunately, yes, it only runs on Windows. It won't run on Mono until there's a runtime out for Linux or for the other OSes. Then it would run perfectly on there as well, of course. The problem with this is, I can write this thing in X11 with widgets and that, but it's just going to be a pain in the butt, right? Come on, So yeah, at the moment, all of this most of this, you will find the source code for as well, except for EOR, because we're not sure what we want to do with it. But Webto, the source code is available. Crowbar, the source code is available. And it's all written in C#, Visual Studio C#, so you can look at it. Any other questions? Nothing. Okay, guys, thank you very much for sticking around for me.